Now let's see the definition of the coordinate system, and let's see what abscissa and ordinates are. Now, if you draw in a plane two mutually perpendicular number lines, x prime x and y prime y, x prime x being the horizontal line and y prime y being the vertical line. So this vertical line over here is the y prime y line, and this horizontal line is the x prime x line. Now, let there be a point of intersection we'll call O, and it is also called the origin of the axis, right? So this is the point O, and it is the zero representation of both of these lines, right? So these are two number lines, and this point between them, the intersection point, is the 0 point. So both of the lines x, x prime, y, y prime, they all start from this point O, and it is the 0 point. Now, the two lines are called coordinate axes. So this line and this line, they are called the coordinate axis. The horizontal line that starts at x prime, goes till O, and ends at x is called the x-axis. So this horizontal line is called the x-axis, and similarly this vertical line is called the y-axis. Okay, so this is just basic stuff. What really this means for simple remembering is that this horizontal line, this vertical line is called the y-axis, this horizontal line is called the x-axis, the intersection point is called O, and if you take these two as number lines, this O is the starting point. And if you, this line over here is the positive x-axis, this line over here is the negative x-axis, hence the name x prime. This vertical line over here is called the positive y-axis, and this vertical line that goes down is the negative x-axis, hence it's called y prime. Okay, this is just basically it, and both of these lines are called the coordinate axis. Now, if xy are the coordinates of a point P, so for example, if you have this line over here, this axis over here, okay, this being the positive y-axis and this being the positive x-axis, and this is the point P over here, right? It will obviously have some x value and it will have some y value, okay? And let's say the x value is 4 and the y value is 5, then this, you can write it down like this, 4, 5, and these are the coordinates of the point P, okay? The first member component of the ordered pair, this is the ordered pair by the way, or 4 and 5, this is also the ordered pair. It is called, this ordered pair is the first member, this member over here, is the x coordinate or the abscissa of P, okay? And obviously this 5 or this y over here, this is called the y coordinate or the ordinate of P, okay? X and y are just arbitrary values, and 4 and 5 are actual values of this example that I've given here. Okay, so for example, if you have, let me just give you another example to clarify this. This is the positive x-axis, the positive y-axis, the negative x-axis, and the negative y-axis. And say you have this point over here, right? Oops, yeah, this point Q. And the y value is 5, and the x value, let's say, is -3, right? Because it's in the negative x-axis. Then you can write it down like this, Q -3, 5, and this 3 here is the abscissa of Q, and this 5 here is the ordinate of Q, okay? Now let's see the definition of a quadrant and the distance formula. So the coordinate axis, so basically the y-axis and the x-axis, right? Y-axis, x-axis, this is the negative x-axis, and this is the positive, negative y-axis. They divide the plane into 4 equal parts, which are called the quadrants. So we have this part, we have this part, we have this part, and we have this part. And basically, quadrant number 1 has all the points with positive x values and positive y values, meaning greater than x values greater than 0 and y values greater than 0 as well. This point, the center point, basically it has x values of 0 and a y value of 0, right? So it's the center point of all the x's. So if you look at this origin over here, all values to the right of the origin have positive x values. All values above the origin have positive y values. All values to the left of the origin have negative x values. All values below the origin have negative y values. So quadrant 1 has positive x and positive y values, which means that it is above the origin and to the right of the origin, which means it's this one, this quadrant. Quadrant 2 has negative x values but positive y values, which means positive y values means it is above the origin, and negative x values mean it's to the left of the origin, which means it's this quadrant. Quadrant 3 has negative x values and negative y values. So negative x values means it's to the left of the origin, and negative y values means it's below the origin, which means it's this one. And quadrant 4 means positive y values and it is negative y values. That's an error. And it has positive x values. Positive x values means it's to the right of the origin. Negative y values means it's below the origin, which means this one is quadrant number 4. Now we've divided all the 4 quadrants. Let's see how you can represent a point P as an ordered pair in this form. So if you draw the axis again, right, y, x, and negative y. So you have this point P over here, right? The x value corresponding to this point P is minus 5, and the y value is, let's say, positive 7. You can represent this P as this, minus 5, 7. This is how you can represent a point P as an ordered pair. Okay? Now, let's see the distance formula. Basically, if you have a point A with x1 as its x value, right, and y1 as its y value, a point B with x2 as its x value and y2 as its y value. Now you can see we're representing them as ordered pairs. You can find the distance between point A and point B using this formula, which is derived from the Pythagorean theorem, right? So just to clear it out how that happened, you have this positive y axis, you have this positive x-axis, the negative x-axis, and the negative y-axis. Say you have this point here as point A, and it has the x value, right, of say this is x1 and this is y1, right? And say you have, let's say, this point B over here, right? And this is x2 and this is y2. Now you can draw a line between them. This will be the distance between A and B, right? This line that connects them. And you can draw this as a right angle triangle like this. So this distance between AB is the hypotenuse of the right angle triangle. The difference between its y values is this one here, right? And this will be the opposite side, right? And the difference between the x values will be the adjacent. So if you apply the Pythagorean theorem on it, the opposite side is clearly y2 minus y1, right? So y2 minus y1 whole square plus the adjacent, which is x2 minus x1, right? x2 minus x1 whole square is equal to the hypotenuse, right? Which is what we're trying to find. That will be AB modulus. And that is where, whole square, by the way. Sorry. And if you take the under root over here, you can cancel this out. And that's how you got this distance formula, right? So yeah, that's it. Now, let's see how we can find the coordinates of a point dividing the join of 2 points in a given ratio. So let's say you have a point A and a point B, right? And if you have to find the coordinates of a point that divides the line segment AB in this ratio, you can find that the coordinates of that point using this method, right? So if you have a plane, right, this is the y-axis and this is the x-axis. Say you have this point here as A, say you have this point here as B, with A having the x value of x1 and the y value of y1, B having the x value of x2 and the y value of y2. Now, this is the line joining A and B. And say you have this point here. Let's call it Q. And you need to find the coordinates of this point Q. And it says that the line that goes from A to Q is of this distance, K1. And the line that goes from Q to B is of this distance, K2, right? This K1 and this K2. Then you can use this method to find the coordinates of this point Q. This over here will give you the x value of Q. And this here will give you the y value of Q. Now, it's not necessary that this will be the distance between A and Q, and the K2 will be the distance between Q and B, right? Basically, let's say that the distance between A and B is, well, 2. And K1 and K2 must equal to 2, right? So, for example, if K1 is, say, 1.2 and K2 is, say, 0.8. So 1.2 plus 0.8 is equal to 2, right? But again, there's another way to go about this. It says that the ratio of K1 and K2 must be given to you correctly, right? So K1 divided by K2 is equal to 1.2 divided by 0.8, which is also equal to 0.6 and 0.4, right? If you divide both of them by 2. And this can also be equal to, if you divide it further by 2, 0.3 over 0.2, right? These are all the valid ratios for this. Instead of dividing by 2, you can also multiply them by 2 or any constant really, but the ratio must be valid. Okay, the ratio must be valid, and if the ratio is given to you, you can find the coordinates of Q, right? So let's see what the inclination of a line is. A very simple concept, really. It says that if you have this line L, right, in the plane, then the inclination of L is basically the angle that is measured counterclockwise from the positive x-axis, right? So you have this line L and you draw this angle from the positive x-axis. That gives you alpha, and that is the inclination of the line L. So another example would be if you have this axis over here, right, and say you have this line over here, then you can basically draw from the positive x-axis, start drawing a circle counterclockwise and end it at this line. Let's call it the line P. So this angle beta is the inclination of the line P. Okay. Now let's see what the slope or gradient of a line is. When we walk on an inclined path, we cover a horizontal distance called the run, and we cover a vertical distance called the rise, both of them at the same time. So if you have this path here and you're going up, right? You're covering this horizontal distance, the run, and you're also covering this vertical distance, right? This is the horizontal distance run, and this is the vertical distance we'll call the rise, right? And it's obviously harder to climb a steeper inclined plane, and the measure of the steepness is termed as the gradient or the slope of the inclined path, and we denote it by m. And it can be found by the ratio of the rise to the run, rise being the y value or the vertical value you cover, and the run being the horizontal value or the x value that you cover, right? So y over x as well. And it is basically also the tangent of the inclination alpha. And let's see what that really means. See, in analytical geometry, slope or gradient, also called m, of a non-vertical straight line with alpha as its inclination is defined by m or tan alpha. If L is a horizontal slope, if L is a horizontal, its slope is 0, and if L is vertical, then its slope is undefined or infinity. Okay, so let's see. Let's draw the coordinate axis, x-axis and y-axis, and let's say this is your line L, right? That means it's starting from this origin, the 0, 0 point, with y value 0 and x value 0, and it ends at this point here, right? Now, the angle alpha, the inclination, you draw a line, you start counting from the positive x-axis and you go counterclockwise. So this is the angle alpha. Okay. Now, you can find m by taking the tangent of alpha. Why the tangent of alpha? Because tan alpha is basically the opposite of a triangle over the adjacent, right? So if you look at this as a triangle, you have this side, you have this side, and you have the line L as the hypotenuse. And tangent of alpha means you're dividing this vertical with this horizontal, the opposite of the adjacent. So it's equivalent to the rise, the y value, over the run, the x value that you cover, right? And again, if this is a horizontal line, that means the angle is 0. And at 0, tan 0 is equal to 0. But if it's a line that lies on the y-axis, that means you have a 90-degree angle, and tangent of 90 degrees is equal to infinity or undefined. And you can think of it really like this as well, that obviously a horizontal line or a straight flat line is easier to walk on. A straight path, a flat path is easier to walk on. So obviously the gradient of it will be 0. And if you have a vertical path, so like a wall in front of you, and if you try to climb that, that's impossible. Hence, it's infinity, right? So another important thing to remember is that if alpha lies between 0 and 90, m will be positive, and if alpha lies between 90 and 180, m is negative. So if, for example, if you have this line over here, that means it lies between 0 and 180 degrees. So it will have a negative gradient. Now, let's see what the slope of a line joining 2 points is, and what are parallel and perpendicular lines, and how they can be related to each other by the gradient. Okay, now let's see how you can find out the slope of a line joining 2 points. If a non-vertical line, so basically m must not be equal to infinity, a non-vertical line, let's say it's the line L, with an inclination of alpha, passes through 2 points P and Q, then the slope or the gradient of the line L is given by this or this, right? So let me explain what this means. Say you have this coordinate axis, right? And say you have this line over here. Okay, this is this is the point P, right? And this is the point Q, right? P has x1 as its x value and y1 as its y value. Q has x2 as its x value and y2 as its y value, right? And its inclination is simply this angle here, right? Let's say it's alpha. Now you can find out the gradient of this line PQ by this formula, right? Say y2 is, well, let's say it's 5, and let's say x2 is 4. Let's say x1 is -4 and y1 is -5. Okay, then you can find out m, the gradient of PQ, by subtracting y2 and y1. So 5 minus -5, 5 minus -5, and dividing it by the difference of x2 and x1. So 4 minus -4. Well, that would be equal to 10 over 8, right? Which is equal to 5 by 4. And that is the gradient of PQ. Or you can find out the value of this angle and take its tangent to get the value of the gradient as well. All of these will be equal. Now let's see how parallel and perpendicular lines are related to each other. If you have a line L1 and you have a line L2 with their respective slopes as M1 and M2, these two lines will be parallel if and only if they have an equal gradient. Okay? And they will be perpendicular if and only if M1 is equal to the negative reciprocal of M2, or M1 into M2 plus 1 is equal to 0. So if you have, say, this line over here, and if you have this line over here, they will be perpendicular if and only if the gradient of this line is equal to the negative reciprocal of the gradient of this line. Okay? Now, let's see what intercepts are, what the slope-intercept form is, the point slope, and what the symmetric form of the equation of a line is. Now, x-intercept. If a line intersects the x-axis at this point, let's say it's a, 0, then a is the x-intercept of the line. And similarly, if a line intersects the y-axis at this coordinate, 0b, then b is called the y-intercept of the line. So if you have this coordinate axis over here, this is the y-axis, the x-axis, the negative x-axis, and the negative y-axis, and say you have this line over here, right? Then the x-intercept will be the point where the line intersects the x-axis, which is this point. Now, as you can see, it has the y value of 0, right? But it has some x value, right? And let's say that x value is a. Then this a over here is the x-intercept of this line. And similarly, this line intersects the y-axis at this point. So it has a 0 x value, right? Because it's above the origin. So it has 0 as an x value. But it intersects the y-axis at some point. Let's call that b, right? So b will be the y-intercept of this line. Okay, so the slope-intercept form of the equation of a straight line is given by this, right? So y is any if you take any point on the line and the y value is this, the x value is this m is the gradient of the line, and this c is the y-intercept of that line, right? So, for example, if you have a line with m equal to 2, and if you have the y-intercept or c of the line is 4, then the equation of that line would be y is equal to 2x plus 4. Okay, so yeah, that's the slope-intercept form equation of the line. Okay, and this is only valid for straight lines, as we were discussing straight lines right now. Now let's see the point slope form of the equation of a straight line. This is the point slope form of the equation, right? So as we already know that m can be given by subtracting 2 y points and their corresponding x points, right? So obviously if you take this denominator to the left hand side, you get this form, and if you just let it remain as it is, you get this form, and this is the point slope form equation of the straight line. Now let's see what the symmetric form equation of the straight line is. Now we know that the gradient can also be written down as tan alpha, right? Now if you write down tan alpha as sine alpha over cos alpha and put it equal to the point slope form, which is y minus y1 over x minus x1, and if you cross multiply both of these sides, you get this, right? And that is equal to some constant r, and this is the symmetric form of the equation of a straight line, right? And yeah, and again, let me remind you, alpha is the inclination of the line, and I've mentioned it again and again what that is. It's the angle between the line and the positive x-axis in the counterclockwise direction. Now let's see the 2-point form, the intercept form, and the normal form of the equation of a line. Now, the 2-point form of the equation of a straight line is written like this or like this. So, if you have a point Q with x1 and y1 as its coordinates, and you have a point R with x2 and y2 as its coordinates, if x2 and y2 are known to you, well then you're golden. You could just use this equation to find the equation of the straight line. So, for example, if this is the y-axis, this is the x-axis, and say you have this line, this is the starting point is point Q, the ending point is point R, right? And the coordinates of Q are x1 and y1, coordinates of R are x2 and y2, and if they are known to you, well, you just plug them in, plug y2 over here, plug y1 over here, x2 over here, x1 over here, and x2 over here, and y2 over here. You know all these points. Well then, you can get it in the standard equation form of the straight line. It's fairly simple, right? Well, let's see the intercept form of the equation of a straight line. Okay, if the x-intercept A and the y-intercept B of a line are given to you, or if you find them out, you can also use this very simple formula to get the equation of the straight line. So, for example, again, let me just draw the axis, and let's just say you have this line, and you know the coordinate of this y-intercept. Obviously, the x value over here is 0 because, well, obviously it's 0. and the y-intercept point is, well, let's just say that's 4. And over here, let's just say the x-intercept, well, the x value would be, let's say, 3. And obviously the y value will be 0 because it's in alignment with the origin. So you have this, well, then it's fairly simple, right? Because A is the x-intercept, which is 3, and B is the y-intercept, which is 4. So it would just become x over 3 plus y over 4 is equal to 1. Well, that's your intercept form. And lastly, let's see what the normal form of the equation of a straight line is. If you have a non-vertical line L such that the length of the perpendicular from the origin to the line L is P and alpha is the inclination of this perpendicular, well, then the normal form equation would be this. Okay, so just to clarify what they mean over here, let's look at an example. If you have, say, this line over here, okay, and you need to find its equation, well, then the perpendicular line that runs from any point over here till the origin, which is this point over here, well, let's just draw it out, right? So you must have a 90-degree angle between this line that runs to the origin and the actual line. Now look at this line that you have formed right now, and the length of this line is P, okay, and alpha is the inclination of this line, so this is alpha. Once you find these two things out, P and alpha, well, then you can find the equation of this line over here by using this method. X cos of alpha plus y sine of alpha is equal to the length of this line that runs from O till the line itself, that is perpendicular to the line itself, and that length is P over here. Okay, so yeah, this is fairly simple. For example, if you had alpha equal to, let's say, 60 degrees, and if P was equal to, say, 4, the length, well, then simply it would become x cos of 60 plus y sine of 60 is equal to 4, and that's your normal form equation. Now let's see what the general linear equation in two variables is, and we'll also transform it into its slope form, right? So the linear equation ax plus by plus c is equal to 0. This equation is in two variables x and y, so these are the only two variables in this equation, and it represents a straight line, okay? And this is the general form of the linear equation in two variables, and a, b, and c are constants. They are not variables. Usually they'll be numbers, like constant numbers or decimal numbers or anything, but they're not variables. X and y are the variables, and a and b must not be 0, because if any one of these is 0, then their corresponding variable that is being multiplied will also become 0. So for example, if a is equal to 0, this entire ax term will also become 0, and hence you'll just be left with one variable y, and we need an equation in two variables. So that's why a and b cannot be 0. Now let's see how to transform it to the standard form. So this general equation must be converted into the form y is equal to mx plus c. And to do that, the first thing you'll have to do is that you'll have to isolate the y term. So first thing is you take the ax and c terms to the right hand side. So by is equal to minus ax minus c. And then you divide this b in the right hand side. So y is equal to minus a over b x minus c over b, right? And as you can see, to convert this thing into this thing, just see what the corresponding values are. So x is being multiplied with m over here, and x is being multiplied with minus a over b over here, right? So m is equal to minus a over b. And as you can see, this minus c over b is corresponding to this c over here. So you can write c down as minus c over b. Because, let me just explain it further. Plus minus c over b, right? And so now you have this general equation in the form of y is equal to mx plus c, where m is minus a over b and c is minus c over b.
Now let's transform a general equation to its slope and symmetric form. Let's see the slope form first. This is the general equation of a line. And now let's arrange it into the form y is equal to mx plus c, where m is the gradient and c is the y-intercept. So let's take this ax to the right-hand side and the c to the right-hand side as well. So by is equal to minus ax minus c, y is equal to minus a over bx minus c over b, and this is your m, and this is your c, or this is the gradient, and this is the y-intercept. Now to calculate the symmetric form, you need to find another point on the line apart from the gradient, apart from the y-intercept. So then the easiest one is to just find the x-intercept. And the way to find the x-intercept is to put this y over here equal to 0, right? Because in the x-intercept, the y value is 0. In the y-intercept, the x value is 0. So y is equal to my bad. Let's take the general equation. It's easier to calculate. So ax plus b into 0, because y is equal to 0, plus c, and that's equal to 0. So now ax is equal to negative c, and x is equal to minus c over a, right? So the coordinates of the x-intercept are minus c over a and 0. Now this is needed for the symmetric form, but for the point slope form, you just need to fiddle with this y is equal to mx plus c equation, right? Or in this case, y is equal to minus a over b x minus c over b. Now what you need to do is, you need to take this slope minus a over b common, right? And that will eventually lead you to this equation, right? And the thing is that you need to have the c over a over here, because if you take minus a over b common from both of these terms, right, you need to divide the c with a, so that when you multiply both of these terms, they eventually give you negative c over b, right? And indeed, in this case, when you will multiply this minus a over b with this c over a, this a and this a, they cancel out, and that eventually leaves you with minus c over b. Okay, and this is now the point slope form, but you won't deal with this much. You'll deal with more with the symmetric form. So we already know that the gradient, or m, is equal to minus a over b, but that is also equal to tan alpha. So if you draw the coordinate axis, and let's just assume that this is the line given to us, right? And this is your alpha, and we already know that the gradient is equal to the rise over the run. This is your rise, and this is your run, right? So the rise is equal to a, in this case negative a, and the run is equal to b, right? So the y value is negative a and the x value is b, and tan alpha is equal to the rise over the run, And so now let's see what sine alpha is equal to. Sine alpha is equal to the rise over the hypotenuse. And the hypotenuse, if you remember the Pythagorean theorem, is equal to a square plus b square whole under root, right? Not negative a square, because negative a square and positive a square is the same thing, right? So now you have this as the hypotenuse. So now sine alpha is equal to a over plus minus under root a square plus b square. And similarly, cos alpha is equal to the run over the hypotenuse. So b over under root a square plus b square. Now that you have this, let's see the equation in the symmetric form. The symmetric form equation was x minus x1 over cos alpha, which is equal to y minus y1 over sine alpha, and that is equal to some constant r, right? And this x1 and y1 comes from the point, which is the x-intercept. So x1 is equal to minus c over a, and y1 is equal to 0. And hence you get, and we already know that cos alpha is this, this, and sine alpha is this, right? So once you plug those values in, you get this. And this is the symmetric form. Now let's transform a general equation to a two-point equation, an intercept equation, and a normal equation. Now, this is the general equation of a line. Now let's convert it to its two-point form. Now we choose two arbitrary points on this equation, and these are two such points, right? The x-intercept of this equation is minus c over a and 0, right? Because the y value in the x-intercept is 0. And similarly, in the y-intercept of this equation, the y-intercept is minus c over b. 0 and minus c over b. And we know that the x value in the y-intercept is 0, right? You can find these out by just rearranging this equation. And the equation of the line through these points is this, right? You know that the two-point form, the general way to write the equation of the two-point form is y minus y1 over y1 minus y2 is equal to x minus x1 over x1 minus x2. This y is the arbitrary y that we put into the equation, and this x is also the arbitrary x that we put into the equation, right? They're just variables. And this y1 and this y2, these are given to us as points, right? Similarly, this x1 and this x2, these are also given as points, right? So first thing you need to do is determine what this y1 is, what this y2 is, what this x1 is, and what this x2 is, right? So these points will be like this, right? x1, y1, and x2, y2, right? And we already know those 2 points, right? x1 is minus c over a, and y1 is 0. Similarly, x2 is 0, and y2 is minus c over b. So just replace them in the equation, right? And you get this. Okay? And this is the first step in the two-point form. Now all you need to do is arrange these into the standard two-point form, in which case what you need to do is you will multiply this over here to the numerator of the right hand side, okay? And you'll eventually end up with this, which is the two-point form. Now let's see the intercept form. The equation that was given to us was in the general form, which is ax plus by plus c is equal to 0. Now when you take the c to the right hand side, you get this, right? And now what you need to do is you need to divide this negative c on the right hand side and replace it with a 1, right? Because if you re-engineer this and take this negative c to the right hand side, it will just give you this equation again. Now that you have this, all you need to do is convert it into this form, right? Because x divided by negative c over a is equal to x multiplied with negative a over c, which is equal to negative ax over c, which is just what we had over here, right? And same goes for by over negative c, by over negative c, yeah. So yeah, all you need to do is, instead of writing minus ax over c, just write x over negative c over a. And instead of writing by over negative c, just write y over negative c over b. And hence, you will eventually end up with the intercept form. Now, let's see how to transform the equation to the normal form. This equation can be written in the normal form in this way, right? All you need to do is take this plus c to the right hand side, which will eventually leave you with ax plus by is equal to negative c. And then what you need to do is you need to take just the magnitude of this a and this b, okay? And that will become a square plus b square under root, okay? And this, when you have this, you just divide it on both the right hand side of the equation and the left hand side of the equation, and then you'll have the normal form. Now let's see what the point of intersection of two lines is, and we also will discuss the condition of concurrency of three lines. Concurrency means that they actually intersect. We need to ensure that the three lines intersect. So this is the general equation of line 1, and this is the general equation of line 2, right? And we have to make sure that these two lines are not parallel, because if they're parallel, right, if the lines are parallel, they'll never intersect. And the way to ensure that they are not parallel, one way is to actually convert the equations into their slope forms. So y is equal to mx plus c forms, right? And then you need to make sure that the gradient, the m of line 1, let's call it m1, is not equal to the gradient of line 2. Let's call it m2, right? But another way, if the equation is given to you in its general form, then just ensure that a1b2 minus b1a2 is not equal to 0. a1 is the coefficient of x in line 1. b1 is the coefficient of y in line 1. b2 is the coefficient of y in line 2. And a2 is the coefficient of x in line 2. Okay, let me just rub this off before it becomes very confusing, right? Okay, now that that's cleared, you know that, let's say this is line 1, and let's say this is line 2. They will intersect at this point, right? This point will have coordinates in x and y terms, right? Let's say that this point here is P, right? P. And the coordinates are x1 and y1. And you can find out the values of this x1 and y1 by using this, right? x1 is equal to b1c2 minus b2c1 over a1b2 minus a2b1, and y1 is equal to a2c1 minus a1c2 over a1b2 minus a2b1, right? So it's just easier for you if you actually note down the coefficients of x, the coefficients of y, and the remaining constants from both lines, and then just place them in these two equations. Or you can actually do this in a much simpler way as well, is that if you actually convert both of these equations of line 1 and line 2 into their y is equal to mx plus c forms, then you can solve them simultaneously and eventually find out the values for x1 and y1, which will be the coordinates of their intersection point. Okay, but for general equations you just use these two. Okay, and just to make it very clear to you how you can use the y is equal to mx plus c form, well, what you can do is, for example, let's say that you have this equation 2x plus 3y plus 4 is equal to 0, and you have another line. Let's say the equation is x plus 4y plus 5 is equal to 0, and then what you can do is you can just take the constant to the right hand side in both cases, right? So these will be your two equations, and now you can just solve them simultaneously, and then you can get the values for their intersection point, right? So now let's see the condition of concurrency for three lines. Concurrency means that they intersect at a point. Okay, so there must be three non-parallel lines, and the way to confirm that, let's say that these are the three general equations of the three lines, and the way to confirm if they're concurrent is that the determinant of the coefficients of the lines must be equal to 0. So you'll draw a 3 by 3 matrix with the A values in one column, the B values in the second, and the C values in the third, right? And just to make it very clear, the A's are the coefficients of x, the B's are the coefficients of the y variables, and the C's are constants, the remaining constants. Okay, so they'll not be coefficients of any variable, they'll just be constants. And the determinant of the of this 3 by 3 matrix must be equal to 0, and in that case the three lines will be concurrent. Now let's see how we can calculate the distance of a point from a line. Let's see how we can calculate the distance between two parallel lines, and let's see how you can find the area of a triangular region with its with the coordinates of its corners being known to you. So if you have a point, let's say the point is P, and the coordinates of point P are x1 and y1, and you want to find the distance of this point from a line, let's say that line is L, and the general equation of that line is this, right? You can find out the distance d from the point to that line by using this formula, right? So ax plus ax1 plus by1 plus c, the modulus of whatever that results in, divided by the under root of a square plus b square. So basically what that means is that a is the coefficient of x in the equation of the line, x1 is the x value of point P, this b is the coefficient of y in the general equation of the line, and this y1 is the y value of the point P, and this c is the constant, the remaining constant of the general equation. And again, this is the same a of the general equation, and this is the same b of the general equation, right? So what simply you'll have to do is, once you get the value of ax1 plus by1 plus c, you just take its modulus. What that means is the absolute value, so it cannot be negative. So for example, if this entire thing results in -2, you'll take its modulus and it'll become 2, okay? And just divide it by under root a square plus b square, and you'll get the distance. And similarly, you can find out the distance between two parallel lines by just taking a point on one of the lines and calculating its distance from the other line, right? Just simple. I don't think there's really much to do about this. And now let's see what the area of a triangle is. So if you have a triangle, right, and its coordinates are coordinates of its corners are given to you, right? So this is point P, point Q, and point R, right? And these are the coordinates of P, Q, and R respectively. Then all you need to do is use this formula, half of x1, which is this, y2, which is this, minus y3, which is this, right? And then add that to x2 into y3 minus y1, and add that into x3 into y1 minus y2. And that's really just it. I don't think there's really anything more to do about this. It's just a very simple formula, and just memorize it or it'll be given to you, and you can use that very easily to calculate the area of a triangle. Now let's see how you can find the angles between two lines. So let L1 and L2 be two non-vertical lines such that they are not perpendicular to each other, right? So let's just draw a coordinate axis. So right, so this is the y-axis, this is the x-axis, and two non-vertical lines which are not perpendicular to each other. So let's say this is line L1, and let's say this is line L2. Okay, now there will be an angle between these two lines. Okay, and you need to see which angle you have to deal with. Okay, so obviously let's say that the shorter angle between L2 and L1 is theta, and the larger angle, let's say that is gamma, right? And you have to deal with the shorter angle over here. Okay, and well, it's just easier to deal with the shorter angle. And again, we'll not concern ourselves with these two angles, because again, this angle is the opposite of theta, so this is theta equal to theta as well, and this is equal to gamma as it is opposite to gamma. So we need to find theta, and the way to find theta is to use this formula. Tan theta is equal to the gradient of line 2 minus the gradient of line 1 over 1 minus the gradient of line 1 into the gradient of line 2. And it's really just that simple. I don't think there's really much to go on over here, but it's a very simple formula, and that way you can find theta by taking the tan inverse of whatever this is, right? So yeah, this is the final formula to calculate the angle between the two lines. And that's, oops, sorry. Yeah, that's it. Now let's see how you can write equations of a straight line in matrix form, right? So let's look at one linear equation first. This is the general equation of a line, right? Let's see how you can represent this in a matrix form. First, what you must do is convert this into this form. Ax plus by is equal to minus c. Now, you need to separate a and b into one matrix and x and y into another matrix. You need to multiply those matrices, and that must equal to a matrix containing minus c. Now you know that matrix multiplication is rows into columns. And the condition for matrix multiplication is that the columns of matrix 1 must be equal to the number of rows of matrix 2. And now look at this. This is the matrix multiplication that will eventually give you this general equation. Now, rows into columns means that you will multiply A with X, add that to B into Y, and that will give you minus C, right? Now, first we must confirm that the columns of this matrix are equal to the rows of this matrix. Now, A, B. This matrix is a 1 cross 2 matrix, 1 row, 2 columns. And X, Y, this is a 2 cross 1 matrix, 2 rows, 1 column. As you can see, the number of columns of matrix 1 is equal to the number of rows of matrix 2, so they can indeed be multiplied. And now again, you must remember that the remaining 2 numbers will give you the order of the resultant matrix, and that must be 1 cross 1, right? And that is indeed 1 cross 1 over here. So A into X, AX plus B into Y, BY is equal to minus C. And that is indeed what we have accomplished. Now, let's look at a system of 2 linear equations. Now again, the first thing is take the C1 to the right hand side, it will become minus C. Take the C2 to the right hand side, it will become minus C2. So basically what that means is A1x plus B1y is equal to minus C1, and A2x plus B2y is equal to minus C2. And look at this. This is the 2 cross 2 matrix A1 B1, and that will be multiplied with xy, right? And A2 B2 also multiplied with xy. So let's first confirm if they can indeed be multiplied. So this is a 2 cross 2 matrix. This is a 2 cross 1 matrix. As you can see, the both matrices can be multiplied as the columns of matrix 1 is equal to the columns of matrix 2 is equal to the rows of matrix 2, and the resultant must be a matrix of the order 2 cross 1, and that is indeed what we have over here, a 2 cross 1 matrix. Now again, A1 into X plus B1 into Y plus B1 into Y must be equal to minus C1. Okay, that's the first equation we've covered. And similarly, A2 into X plus B2 into Y plus B2 into Y is equal to minus C2. That's indeed the second equation. Now let's look at a system of 3 linear equations. And again, let's do this ourselves. What will this become? This will become A1 x plus b1y is equal to minus c1, a2x plus b2y is equal to minus c2, a3x plus b3y is equal to minus c3. Now again, the first matrix will have simply 2 columns, but in this case 3 rows. So A1, A2, A3, B1, B2, B3. They will be multiplied with the matrix, with the variable matrix x, y, right? That will be equal to minus C1, minus C2, minus C3, this matrix. Now, as you can see, this matrix is of the order 3 cross 2. This matrix is of the order 2 cross 1, right? And they can be multiplied indeed, as the columns of matrix 1 is equal to the rows of matrix 2, and the resultant matrix must be a 3 cross 1 matrix, and that is indeed what we have over here, a 3 cross 1 matrix containing the constants. And again, a1 x plus b1 y must be equal to minus c1. We have the first equation, a2 x plus b2 y must be equal to minus c2. That is indeed the second equation, and similarly we have the third equation, a3x plus b3y is equal to minus c3, and that is indeed the third equation. And this is just how you simplify linear equations by converting them into matrices. Now let's see what a second degree equation is and what a homogeneous equation is. So a secondary equation is just multiplying two general equations of a linear line, right? If you just multiply two general equations of a line and equate that equal to 0, you get a second degree equation in two variables, the two variables being x and y, right? Okay, that's just simple enough. Now let's see what a homogeneous equation is. Now, if we let a function in the variables x and y be equal to 0, so for example, if you have let's say 2x plus 2y is equal to 0, right? And this is equation 1. It is called a homogeneous equation of the degree n, which is a positive, which must be a positive integer. Then you can apply this rule, and it will make it a homogeneous equation, right? So say you have f of kx and ky, k being a constant, and basically in this case you have 2 as that constant. Then you can apply the function of xy and take the k outside. So you can write this down as 2x plus 2y, which is basically just f of 2x to y. You can equate that equal to 2 into x plus y, or 2 into f of x, y. And hence this is a homogeneous equation.